Okay, welcome everyone. This is the introduction video to Chem 401. You should be enrolled in the section 16712. So our lectures, this course is hybrid. So our lectures will be recorded on video. They'll be available at the start of each week on Sunday. And they'll be posted in Canvas for you to access. You'll also see a worksheet or an outline that goes along with the lecture that you should download and take notes into. How you take notes into this worksheet, it's completely up to you. You can even take notes in a different way. Even if you say, like, I don't want to do my notes in that worksheet because maybe it feels too structured for you, or some of you may have a whole note-taking system that works for you. That's perfectly fine. Whatever you take notes into, you will upload every week at the end of the week on Saturday. And this is for credit. This is a part of your lecture homework credit. And the reason that I'm doing this is as a way, if you're anything like me, you need accountability, right? It's a human thing. So this is how we are building in accountability to make sure that you are watching the lecture videos each and every week. Ideally, before you at least have started watching the lecture videos before you've come into discussion. However, depending on when your discussion falls, right? If you're on Tuesday, you may not have gotten through all the lecture videos. But you definitely want to get through all the lecture videos by the end of that week. Hence why the worksheet will be due that Saturday. What I invite you to do in this moment is to pause the video and decide, when will I watch lecture videos? Put it in your calendar. A suggestion could be Monday and Wednesdays, right? Schedule out an hour and 20 minutes on Monday, an hour and 20 minutes on Wednesday, however you do it. But go ahead and take a moment to schedule it, put it in your calendar as another form of accountability, right? So that you're not on Saturday scrambling to watch the videos and then uploading the assignment, right? You have watched the videos. All right. So that's my rant about the importance of watching the lecture videos the week that they're posted and watching them earlier in the week so that you are on schedule with what we will cover in discussion in lab, and then also the accountability around making sure that you submit your worksheet at the end of the week. So giving you a little bit of idea of what you can kind of expect from these videos, they will be short videos. They will be short videos on different topics. So this first video is just an introduction into the course, what we will cover, what you can kind of expect, and then some things that I think are important for you to be thinking about for you to be successful in this course as we begin our journey together, because this is a journey. We are journeying together for the next 16 weeks, and I'm so excited and honored that I get to be your guide on this journey. And I want to give you as many tools of success to support you in this journey. So one, if you have not watched or gone through, have gone through and read module 0, I want you to pause this video and go and do that now, right? Go through module 0. Also, make sure that you look at the syllabus as well as the calendar that is posted in Canvas. If you haven't done that, pause, go do it now. All right, welcome back now that you've done it. So what will we be discussing in Chem 401? You all have gone through General Chemistry 1 or Chem 400, which really gave you an introduction into general chemistry, learning about atoms and molecules and chemical reactions. Chem 401, we will be looking specifically at really diving into chemical reactions, right? And everything that's underneath it. So we'll start with talking about thermodynamics, which is probably one, if not my favorite subjects in Gen Chem 2. Thermodynamics tells us if a chemical process or reaction, right? I use the word process and reaction interchangeably, can happen on its own, or if we need some type of outside intervention, if we need to input some energy. Then we'll flow to kinetics. We'll flow to kinetics. And this is all about if a reaction happens fast enough to matter, right? Looking at the speed of the reaction or not. Looking at the pace at which the reaction happens, right? Because when we have a reaction that's happening, some reactions are super slow, some are fast, and there are things that we can do to speed up a reaction. So kinetics is all about the flow, the rate at which a reaction happens. From there, we'll go into equilibrium. And this is really getting into the balance point between the forward and reverse process. Because even though when we write a chemical reaction, right, we go from reactants to products, that's what we're actually writing. But what's happening is that the reaction is going in the forward and the reverse process, right? We're going from reactants to products, and then the products are going back to the reactants. And so equilibrium will look all into depth of that in terms of the balance between the forward and the reverse reaction. From there, we'll look at acids and bases, which is a specific type of equilibrium in solution. We'll talk about another class of equilibrium reactions, aqueous ionic equilibria, which, again, it's another class. So we have acids and bases, and then we'll look at these other types of reactions like dissolution, like if we dissolve a salt in water or in some type of solvent, what understanding the equilibrium of that reaction. From there, we'll go into coordination chemistry, and this is all about structure and bonding that drives stability and reactivity. So we'll see really cool colors, right, when we form these different coordination complexes that result in certain colors. We'll get into light. We'll get into understanding more about transition metals. So we'll really be in the transition metal area of the periodic table when we talk about coordination chemistry. From there, we'll talk about electrochemistry, which, as it sounds, right, electricity. How can we harness, basically electrochemistry, we have these reactions that happen spontaneously, and we'll talk about what spontaneous means in thermodynamics. But electrochemistry is basically how we can take these spontaneous processes and harness the energy of those processes for something that's useful, like batteries, fuel cells, electricity. So we have reactions that happen spontaneously, and we can use that spontaneity to harness the energy for something that is useful. From there, we'll go into nuclear chemistry, where we'll talk about extreme changes at the nuclear level. So up until nuclear chemistry, we'll be talking about chemical reactions in the way that we think about them, right? We have molecules that are transformed into another molecule, right? Where we're breaking apart different bonds and forming new bonds. But with nuclear chemistry, we're all in the nucleus. So we'll talk about how to actually write a nuclear reaction and the different types of nuclear processes. We'll end on organic chemistry, which is focused all on carbon-based molecules, right? Which is super important because most things in nature that are natural, right? Most things in nature, we are all made up of carbon, right? So we'll touch upon this, and for those of you that are going to continue in chemistry, then you'll go more into depth into organic chemistry next. All right, so the common thread throughout all of these topics that we're going to talk about is really understanding how and why chemical processes or chemical reactions happen. So this is just an introduction into what we will talk about this semester. One thing that you all know from Chem 400 and even before that is what we mean when we use these words universe, system, and surroundings. I want to do a recap here because this is really, really important, because we will be studying different systems, right? And it's important that you understand what we mean when we say system and what we mean when we say surroundings. So if I'm showing here a beaker of water, so let's say I want to add some salt into this beaker of water. And what I am actually studying is how well the salt dissolves in the water, right? Our system in this case is everything inside the beaker. It's the water and it's whatever salt that I add, right? So our system is what we're studying. The surroundings in this case is the beaker, right? Because if we had the water and the salt in some other container, that might impact the dissolution of salt, right? Or whatever we're studying, whatever reaction we're studying. So it's whatever container, which in this case is a beaker, whatever the beaker is sitting on, our lab bench, and the atmosphere, right? Is this beaker sitting on a hot plate where we're actually heating up this water salt solution? Or is it at room temperature, right? Is it sitting in a window? So it's everything around the system that is basically can either absorb or provide heat to the system. That's our surroundings. And then together, the system and the surroundings makes up our universe. So again, system is the reaction or the process that we are studying, right? So what specific reaction or process we're studying. The surroundings is anything that can receive or give heat to the system. Anything that receives or gives heat to the system is our surroundings. One of our early experiments, calorimetry, will dive deep into this, and one of the fundamental things you need to really understand is what is your system and what is your surroundings in that experiment. So that's why I'm recapping this. If this does not make sense to you, or you're just like, I don't really remember this, go back online, go find a video and review system surroundings. Khan Academy is a source that I really love. I've put it in the syllabus. You can also review lecture notes from a previous chemistry class or just go on YouTube. But I really, really love Khan Academy, so that's always going to be my go-to in terms of outside resources. You can also go to the textbook as well. All right. So this is an introduction into what we'll cover this semester. The last thing that I want to leave you with in this video is how to stay well. This is really, really important because this course may challenge many of you, right? My hope is that it challenges all of you, because challenges it's a positive thing. That means that you will grow in some way. So many of you will be challenged in different ways, whether you're challenged academically on the content, whether you're challenged in your ability to critically think, whether you're challenged in your balancing with all the other things that you have going on, because you all are whole people, right? You have whole lives. So before you embark on this journey, really take time to think about how you will stay well. This is something that I even do as your guide on this journey, right? As a professor, I think about how am I going to stay well as the semester takes off for the next 16 weeks. So I've put some suggestions here for you. Add to, take away, whatever works for you. And these are some things that are evidence based, right? Like moving our body, exercise is important. Find something that you love to move, that you enjoy doing and moving your body, right? For me, I love dance, I love walking, I love yoga. So these are the ways that I move my body. Um, Aim for consistency, shed perfection. This is really important in terms of mentally staying well. Aim for consistency. Showing up consistently to the course will help you do well in the course and release perfection. So when you come into lab, right, you're working on experiments where we have an idea of what results you should get, right? But you may get some new results that we haven't seen. There may be something that went wrong, a mistake that was made that led to the result, that led to you getting a different result. I care more about you understanding what went wrong and conceptually what's happening versus if you did the experiment perfectly, right? I don't grade you on how well you did the experiment. I grade you on completing the experiment, how well your lab report is written up, and how well you understand conceptually what's happening, right? Consistency is also making sure you have a good structure for when you would do the lectures or completing the homework, right? Just consistently showing up to the course daily, or if it's 3 days a week, that I will leave to you to decide, because some of you will need to spend time with this course every single day. Some of you will show up to this course maybe 3 or 4 times a week, and that is all the time that you need to put into the course. But be consistent, right? One time a week outside of when we see each other in discussion and lab won't be enough, right? So develop a consistent pattern, release perfection. Listen to music. So when you complete the student profile that is embedded in Module 0, one of the questions I ask for you to answer is to share some of your favorite songs and some of your favorite music genres. And the reason that I ask this is because in discussion and lab, I usually play music, right? Music is a great way to uplift us. It's a great way to calm us. And I like to play different type of genres that will be uplifting and calming for you. So we will have a playlist for the entire course. So please do make sure you add songs into that. And I will share this playlist on Canvas for all of us that you can use whether you're studying. If you need it to be silent, maybe you listen to this playlist before you study, during study breaks. However you want to use this playlist, you get to use it, right? But music is a really powerful way to stay well, to uplift us, to calm us, to just keep us in high vibration. Explore all the student resources. I have included some in Module 0 as well as in the syllabus. And there is, as I learn about student resources, I'm adding them, right? Go to the student resource page on SCC's website, as well as Los Rios District, right? The other community colleges as well. Take advantage of them. Explore them all. Try them all, and the ones that really resonate, engage them, right? Such as tutoring. There are resources and just community based on ethnic group, your major, different interests and hobbies that you have. Community resources are important. You get to be supported. You should not be doing any of your academic journey in silos, in solitude, and struggling in silence, because there are literally people whose job is to make sure that you have resources to win. So engage those resources. I love meditation. Meditation also is something that has completely changed my life. It's something that I incorporate into my daily practice, different ways to meditate. I invite you to explore that. If you have questions about any of these that I'm sharing, this is something we can definitely chat about during office hours. One other thing I want to mention is eat energizing and nourishing foods. This is so important, you all. I will find this on campus. So there's something called Panther Cares where you can actually get free food, right? So you get to be nourished. You should never be hungry. You are worthy of being nourished, and there are resources to make sure you have food. There are also resources that will teach you how to cook. If you're anything like me, I enjoy cooking, but I don't enjoy cooking for long hours. I like it to be simple and fast. And yes, you can still do this in a way where the food is nutritious. So, this is something that I'm happy to share with you. And there are also resources on campus and also online, right? People have whole Instagram pages on this very topic, how to eat on a budget, how to cook nourishing and nutritious foods that take less than an hour or less than 30 minutes to cook. It's really, really important that your diet is energizing and nourishing. And the final thing that I will leave you with is have fun, right? Remember when learning used to be fun? Like, I came into chemistry and in science because when I was a kid, it was fun, right? You got to use your imagination, explore things, like problem solve. It really was fun. And I don't know where in our educational journey that learning becomes so damn serious. And in this class, I don't want you to take yourself serious. I will not be taking myself serious and I will not be taking you serious, right? I will be holding us accountable. I will be holding you accountable in your learning and in turning your assignments in and in doing the work, obviously, right? But it doesn't have to be so serious and rigid, right? It really gets to be fun. We get to laugh. We get to be our authentic self. When you come into class, I don't want you to leave parts of you. I want you to bring all of you, your ethnic background, your values, your beliefs, your hobbies, your interests, your creativity, right? You all are dynamic and beautiful and brilliant because of all the parts of you. So bring all those parts into the classroom because that's really how you'll excel, right? That's really how you will excel. There's life experiences that have prepared you for this moment, that have shaped you in your thinking to navigate a course such as this. So I want you to bring all of that into this course, and I want you to have fun. Every day, figure out how can I reground, recenter, and connect to the fun. All right. So I'm going to pause this video. Next video, we will jump right into thermodynamics. And I am going to stop sharing my screen. I'm actually going to turn off my video, but I'm going to leave you with a song that has really just been resonating with me. I'm really big on music, and I will be sharing music with you all throughout this course. And if you want to, if you're like, I'm moving through the videos, you can definitely pause this video and jump into the next video for sure. There will be a pop quiz though on what song I played. Just kidding. But just listen to this song. Let the words move you however they do as you embark on the remainder of the lecture videos.
You want things to go well, but you know you survive.